Good day, everyone. Today we will be discussing another past board exam problem taken from the May 2018 HPGE board exam. So, problem number one, it states that if air had a constant unit weight of 12 Newton per cubic meter, what is the decrease in pressure in kPa of an aircraft climbing at an altitude of 3 kilometer? So what is the solution for that? So if we can recall the formula for pressure, that is uh, pressure is equal to unit weight times the height. And since we are talking here about the changes in pressure, we can rewrite this formula as the change in pressure is equal to unit weight times the change in height. Of course, our unit weight is constant. The changes there is from the pressure and the height. So if we can substitute that to our formula, the change in pressure is equal to 12 Newton per cubic meter times what is the change in height? The change in height is 3 kilometer. So that is in meter. So that is 3,000 meter. So we can cancel units here, meter, and we can also cancel 1 degree here. So it will uh, be 12 times 3,000, that is 36,000 Newton per meter squared. No other um, term for Newton per meter squared is Pascal. But since our problem states that the final answer be in kilopascal, we have to convert that one, 36,000 Pascal times 1 in 1 kPa, there are 1,000 Pascal. Cancel. So our final answer, change in pressure is 36 kPa. Of course, since this is a decrease in pressure, so our sign there is negative 36 kPa. So, but in the choices, it actually takes the absolute value of the answer. So that is 36. Letter C. Next, at the foot, problem number 2, at the foot of a mountain, a mercury of specific gravity 13.6 barometer reads 800 millimeters of mercury, and at the same instant, the top of the mountain barometer reads 500 millimeters of mercury. Assuming air is constant at 12.01 Newton per cubic meter, evaluate the approximate height of the mountain. So if we can illustrate that problem, we have 2 points. This one, um, point 2. Let's say we call this one as point 1. We call this one as point 2. So at point 2, at point 2, or the top of the mountain, the barometer reads 500 millimeters of mercury, while at the top, at the foot, the mercury reads 800 mmHg. Now, assuming that the air is 12 Newton per cubic meter, what is the height of the mountain? Now, if we can recall also the formula for the pressure between 2 points, recall, P sub 1 minus P sub 2 is equal to unit weight times the height. Now, the pressure at point 1 minus pressure at point 2 is equal to unit weight times the height. If we can substitute that one, we can also recall again that pressure is equal to unit weight times height. So if we will substitute that one, P1 minus P2 is equal to unit weight times height. P1 is unit weight times height, that is 9.81 times 13.6, since at point 1 we are using mercury barometer. So mercury has a unit weight of 9.81 times 13.6, while the height is this one, 0.5 mm Hg. Now at point 2, that is 9.81 times 13.6 times, no, this one is not, sorry, this one is um, 0.8 minus this one is 0.5 is equal to unit weight. This unit weight is the unit weight of the fluid. Now the fluid there is the air. So the unit weight for air, as stated in the problem, is 12.01 Newton per cubic meter. But for uniformity of our unit, since we used here kilonewton per cubic meter, we have to convert 12.01 Newton per cubic meter into kilonewton per cubic meter by dividing it by 1000 times the height. Now this is what we are looking for, the height. If we can simplify this one, we can say 9.81 times 13.6 times 0.8 minus 0.5 is equal to 12.01 over 1000 times h. So what is the value for our h? 9.81 times 13.6 times 0.8 minus 0.5 all over 12.01 over 1000. So our height is 3,332.62, or from choices, that is 330 meter. Letter C. Next, for problem number 3. Lacking of mercury, an improvised barometer uses a liquid that weighs 0.735 times that of the um, mercury. Assuming that unit weight of air is constant at 12 Newton per cubic meter, evaluate the approximate height of the mountain in meters if the barometer reading are 600 at the base and 850 at the top of the mountain. So actually, it is just the same problem as problem number 2, but only that we will use other um, fluid for our barometer, not the mercury. So this is point 2, point 1, and the reading there is 600 at the base and 850 at the top. Actually, um, this is top, and this is base. So at point 1, that is 850 mm. Point 2, that is 600, just an error. So I will not write mmHg since it is not mercury. We're using a liquid that is 0.735 times that of the mercury by weight. Okay, so what is this height? So using the same formula, P sub 1 minus P sub 2 is equal to unit weight times height. So P sub 1 is 9.81 times 13.6. This is the unit weight of mercury. But since we are using a liquid that is 0.735 times that of mercury, we have to multiply this one by 735. And then, uh, to make our solution shorter, we can follow this one. Okay? So, since it is just the same, at point 1, at point 2, we are using the same fluid. Okay? So, times at point 1, that is 0.85. At point 2, that is 0.6. It's equal to 12. Again, divide it by 1,000 to make it kilonewton per cubic meter times the height. Height, therefore, is equal to 9.81 times 13.6 times 0.735 times 0.85 minus zero point 0.6 all over 12 over 1,000. So our final answer is 2,042.93 meters. So from the choices, our answer is 2040 meters. So that is letter A. So B, that is problem number 2, that is letter C. So okay, you can take a screenshot of our final answer. Thank you for listening.